All right, here we go. So this is the very first time, you guys have always done angles and degrees, and this is going to be the very first time that we use a new unit of measure. It's like metric and imperial. They do the same thing, they just have different measures for each angle. How many degrees are in a full circle?
360.
360. Okay, so if we have a full circle, we have 360 degrees. If we have a full circle, those are very terrible circles. With radians, it's going to be approximately 6.28 radians. Or, here, let me put the approximate sign in there. Or 2 pi. So, degrees, radians, very different. This is going to slice this pi into 360 pieces. So degrees are actually quite small. And then radians are only going to slice this pi into like 3 1/3, or 6 1/3, sorry. So pieces are much bigger. So a radian is a much bigger angle measurement than a degree. So just like imperial and metric, we're going to be, for the very first time, walking into the world of radians. And you need to go back and forth between the two. Good times. Okay. We're going to do a lot of things with measuring angles. The initial arm is where the angle starts. So where you're measuring from is called the initial arm. You're going to do a lot of stuff with measuring angles on coordinate plane. And so the initial arm starts where x is positive. So it starts, most angles start from here. Okay? So when we're doing it in a coordinate plane, we're measuring an angle measurement around the coordinate plane. We're going to start from the positive x-axis. So initial arm. Anybody want to guess where a terminal arm is? Where the angle ends.
So it's the same thingy.
No.
So it's the same stick.
No.
Are you not listening or what?
Maybe he needs the picture, and maybe we're not understanding what Rahat's saying.
I think we all understand what I'm saying.
Shut up, Sue.
You guys, you just need to find some kindness in yourself.
I think we'll find time.
Whoa.
Steve, too soon.
John, what has ever said such a rude word?
So this is where the angle ends. And again, we start here and we measure in a counterclockwise direction when we're using the coordinate plane. And we'll go over this a little bit more, but positive angles are always measured in a counterclockwise. Negative angles are measured counterclockwise. Negative angles are measured in clockwise. We'll go through that a little bit more as we go through, but these are things that are going to be coming up. Oh, look, positive angles. Positive angles. And this abbreviates to CCW, counterclockwise. You see that abbreviation? That's all it means, counterclockwise. And you guys have been doing this all of your lives. Do you guys remember in like grade 7 and 8, you got your protractors out and you measured them?
We never got to those units.
You never got to those units?
No.
Okay, well, some of us did. And when you get a protractor out, you lay it against the horizontal, and you usually measure upwards to the terminal arm. And think about it, that's going in a counterclockwise direction. These will result in positive angles. So if I were to draw the picture, my angle starts here, on the positive x-axis, and I measured it here. Put my terminal arm in. So this would be a positive. Oops, I knew that was going to happen. Sorry, I'll get out of the way. It's just I can write right in front of the board. So if we're going in a counterclockwise direction, we could say that that angle is a positive 105 degrees. Okay, so negative angles measured in a clockwise direction. And we have never touched on negative angles before. We've all lived our lives in degrees and positive when it comes to angle measurement. And now we're opening up the door and we're going to do radians and we're going to do negative angles.
So when did you grad?
We don't in this course. We don't do gradients in this course. Okay? Future math courses will do it, but I think living in the degree and radian world is going to be difficult enough. Let's not add in a third. What did I say this was? Let's say that's 110 degrees. Let's just write that on there because that's going to. And the abbreviation for this one is CW, clockwise. So again, my angle is going to start on the positive x-axis. There's my terminal arm. But if I'm measuring it as a negative angle, I'm going to measure it starting here and coming around this way. So we said positively this is 110. Positively this part is 110. So what is it negative?
Negative.
Negative who?
Negative 2.
Yes, negative 250. Because what do we know the measure is? On a circle. What do we know the measure is on a circle? 360, right? So if you're going 110 in the counterclockwise direction, same measure, negative 250. How does that make you feel? Kind of makes sense, but we've never ever done it before, so.
So we did this in class too.
We didn't. I didn't. Maybe you did. I did give you a textbook. Okay. Obtuse angles. Maybe let's go to acute angles. What are acute angles?
Or less than 90.
Less than 90. Oh, probably more words in there. So angles that are less than 90 degrees, they go between 0 and 90 in a positive measure. Obtuse angles,
More than 90.
but less than 180. So obtuse angles, I'm going to write it like this, and you may not like this. So theta has to be greater than what? Greater than 90. Is it equal to 90? No, because what's a 90-degree angle called? A right angle. So it's special. So obtuse angles, theta is greater than 90, but less than. How does that restriction make you feel? What quadrants are you in?
Quadrant 1 and 2?
For an obtuse angle, where are you?
2.
Quadrant 2. So we got greater than 90, but less than 180. And you need to make sure that you have the angle measurements in there. Because we're using a different unit of measure now, units are they've always been super important, but they're super, super important here. I think we all know this, but maybe seeing it like this isn't as comfortable as saying the words. Okay, complementary angles. Complements are add up to 90, supplement add up to 180. I feel like we did do this last year. We didn't do negative angles, but we did supplementary and complementary, didn't we?
No, we did.
No?
What angle it needs to get to the next 90 degrees.
Okay.
Is it referencing?
Yeah, that's what.
Oh, that's coming up too.
Oh, no, no.
Why?
Do you know how I remember this? A compliment is nice, but taking me to supper is better. And that's how I remember it. Kind of cheesy, but it has locked it in my brain that 90 is a very nice number, but 180 is bigger. Okay? So, how you choose to remember it, it's up to you, but that's what's stuck in my head. I don't know where I picked that up. It's probably a million years ago, but that's how I remember those two. You don't use it a ton, but the language is important, so you need to know what that says. Okay, so that was a lot of vocab. Now, let's do some math. Okay, what's a radian? We know this.
Unit of measure?
Unit of measure. And it's specifically used to measure angles. That's a really big space for two words. It's just an angle measurement, just like a degree. But like I said, it's like imperial-metric. Both do the same thing, but would you rather run a kilometer or a mile?
Kilometer.
I hope you all want to run a kilometer. Kilometer is a shorter distance than a mile. I'm going to tell you that if you run a half marathon, it's 22 kilometers or 13.1 miles. Same distance, but 22 sounds a lot more impressive. Okay, like I said, we're going to be putting things on the unit circle. Okay, we're going to be putting things on the unit circle, and we're going to start remembering where our radian measures are, and we're going to link them to our degrees. Okay, so all this is a circle put on a coordinate plane. That's what a unit circle is, because what is the radius of the circle? The radius of the circle. 1 unit. So we call it a unit circle because it has a radius of 1. So from the center point to the circumference of the circle, from the center to the circumference is 1 unit. That's going to be important later, so tuck that away. What's the distance from the center to here? Still 1 unit. Center to the circumference is a unit of 1. Okay, good job, everyone.
How come that's 1 2?
Pardon?
How come that's 1 2?
Okay, I don't know. A radius is going to be the same distance from
radius.
the center.
Yeah,
The radius is going to be 1 unit.
Oh, radius.
Radius is 1 unit. Okay, you can leave that on there if you drew that line, but we're going to do some connections. This is where we start to lose our calculator. Okay. So, remember what I said 260 was in radians? It was 6.28 approximately, or
I got you.
pi times 2. So 360 is 2 pi. That's usually how we say it, is 2 pi, like 2x. But just remember that pi is an actual number. It's just not a nice number, it doesn't end. So if you were to put 2 pi in your calculator using your pi button, grab your calculators and find the pi button.
I thought you said that.
I know, but just for this. Just, are you okay? Yeah. I switched gears on you. I'm like, no calculator, calculator. Just disrespectful like that. What do we get?
6.2831852.
2831.
No, 3185307.
So, really important, ladies and gentlemen, that you use your pi button. That you use your pi button on your calculator. 3.14 is a very truncated, a very rounded answer for the digits of pi. So your calculator already has a pi button built in, so it will take as many digits as it can calculate. Okay, so let's do some math. Let's math it out. 360. So 360 is all the way around. Where's 180? Halfway around. You guys agree with me? 360 all the way, 180 is half. So if 360 is 2 pi, what's half of 2 pi? Pi. 159. I'm just going to put some ellipses. All right. So if 180 is halfway around, where's 90? Half of pi. So pi over 2, pi by 2, half of pi. I'll take all of this. Okay. So now we got to do some mathing. 60 degrees. Pi over who? 3. How did you get that? So Steve is saying that 60 goes into 360 6 times. So that would mean we take 2 pi and divide by 6. Or 180, 60 goes into 180 how many times? 3 times. And 180 is pi. So 60 is pi over 3. I've totally given up on the calculator about it. But you guys can do that. You can figure it out. Okay, let's jump to 30.
5 by 6.
5 by 6. Hey. So we could do 90. We know 30 goes into 93 times, so we're going to have to divide pi over 2 by 3. So that's going to give me pi over 6. 45. 45. Pi over 4. Because 90, 45 goes into 90 twice. So we're going to take pi over 2 and divide it by 2. So it's going to be pi over 4. That's a bad pi. You get the idea. Okay. So, now what? 180. Pi by 180. You could have done 2 pi by 360, because there's 360 degrees in a full circle. We didn't want to reduce that fraction, so we did pi by 180. Okay, these you need to commit to memory. These are our most used values on the unit circle in quadrant 1, and then we are going to apply our knowledge of angles to get to the angle measurements in all the other quadrants. So I need you to be able to go back and forth between these two.
Would like a calculator?
Yeah. Because honest to goodness, guys, we're not going to use this column. Well, we might when we get to solving equations, but we're not gonna use this column very much. We're gonna live in radian measure and degree measure. Okay? So emotionally prepare for that. Okay, nobody's crying yet. I like it. All right, we gotta convert. So what happens when it's not a nice value like 30, 60, 45, 90, 180, 360?
You have to divide by 16 and multiply.
So if we have a degree, if we have, let's say, 20 degrees, that's not on that like nice list that I have to memorize. You're going to do some mathing. How much is each degree worth? How much is each degree worth? 5 over 180. So we are going to multiply by
Whatever our number is, multiplied by pi divided by 180.
Never ask you.
okay? So it's taking the degrees, multiplying it by that factor, and so we would simply take 20 times it by pi over 180. What are we going to do? We're going to reduce, right? Hopefully everybody's going to reduce. Zeros can cancel each other out, and we're going to be left with pi over 9, because 2 becomes a 1, the 18 becomes a 9. I was trying to teach my grade 9 this, and they really struggled with it.
Wow.
But they're learning, right? They're learning. Okay, I don't think we need to do example A just because we've already done that. Can you guys do 25 degrees? Can you guys try 25 degrees? Somebody feel bold enough to put on the board? Anyway? Okay, I'm going to put the marker back here. I'm going to go run and...
Please, God. Do it.
Please! She did say that. She just texted me. Do it.
No, no one took me up on the offer?
Miss Cameron, why don't you put in a decimal something your last name?
Okay. So I think the big thing here is the math isn't hard. I don't think the math is hard, but you got to remember to leave it as a fraction, and you want to leave it in terms of pi. And the reason why is we want to kind of put our calculators to the side for a bit. So this will be the first unit on your test where a portion of it will be calculator and a portion of it will be non-calculator. Okay? And you guys know on your final exam, your usually up to 6 questions are with your calculator, and you have 45 minutes to complete them. After that, calculators get taken back, second booklets get handed out, and you have the rest of the time to finish without a calculator. Okay, how many times can I reduce this? 25 over 180? Okay, how many times does 25 go into 180? Up to you.
25 doesn't go into 180.
Okay.
If you take
Can I take 5 out?
Yeah.
So what do I get if I take 5 out? I got 5 here, what's the 36? 36. So my answer is going to be 5 pi over 36.
It is 7 times.
Did everybody get that okay?
I did 5 over 7 times.
Now, no decimals in our fractions, and the idea is that you're getting comfortable, so comfortable with number sense that you can reduce fractions pretty easily.
Oh, that makes sense.
Can I put it where?
Yeah, never mind. It's all good.
Okay. 108. 108. Oh, guys, I didn't say this, but I needed to, and I totally forgot to say it. Radians don't have a symbol for their units of measure. So notice on all of these, I have them put like the word radians after it, or R for units of measure, like degrees have the little bubble, the superscript bubble. You don't. Well, you do know. If it doesn't have a unit of measure, it's given a gradient. Well, it's going to be in the context of a question, hopefully. If you stumble across this, you can't be certain it's an angle measurement. So if you have a troll that needs you, and you need to answer a question, and he throws this at you, you're like, is that a length measurement? You won't know. Tell the troll you need more information. Now, if you want to write the word radians after it, you totally can. There's nothing wrong with it. But leaving it blank implies that it is radians. So if I'm struggling with my number sense and I'm not sure what to do, I know both of these are divisible by 2. And it might take me some time, but 108 divided by 2 is 54. 180 divided by 2 is 90. Can I go further with that?
You can go way further than this now.
What can I take out?
Okay, so first of all, standard going to I was just thinking 9.
You're going to take 9 out?
Yeah.
Does 9 go into 108?
Yes?
What is it?
12.
12. Okay. So we're going to take a 9 out. Ooh,
That's 20.
That's not true. That's going to leave me with 2.
That was amazing.
Okay. But am I done here?
What?
I hope nobody walks away at this point. What can I still do here? I can take a 4 out. And what am I left with? 3 pi over 5. The smaller you make these fractions, the easier they're going to be to do more math with them later. So get into the habit of getting them into their smallest part. Yeah, Dion?
What if you get a prime number like 7?
Then you can't reduce.
So what would it be?
Like 3 is prime and 5 is prime. So this is it.
You just put 7 pi over 1.
Yeah. Yeah, you'd be done.
What is this counting?
Yes.
Will there be any brackets here?
Yes. No, maybe not this.
What?
No, there won't be in this unit. Wait till you get to chapter 5 and graphing. Okay. All right. Okay, so if we want to go the other way, if we have radians and we want our answer in degrees, we have radians but we want our answer in degrees, we're going to do the reciprocal. I've mixed multiply and by all of the things. What's the reciprocal? 180 over 5. Okay, so we're going to multiply by 180 over 5. And I remember this because radians usually have pi's in them, and we want to get rid of the pi, so we're going to divide by pi. That's how I remember the conversion. So if I want to convert this to degrees, I have pi over 4 multiplied by 180 over pi. What happens? Pi's cancel. That's a good thing. And remember, pi is just a number, so if you end up with pi in your answer, it's not the end of the world, but it usually doesn't happen. Does 4 go into 180? Yes. How many times? 45 times. I could reduce it. It could be 90 over 2, and then 90 divided by 2 is 45. But what I need here, most importantly, what unit am I in? Degrees. It has a symbol, so you have to use it. Okay, can you guys do the next one?
Nope.
Yep. I have faith that you
Where do
can.
you think I am?
I think you're a mathematical genius.
Holy smokes. Please, let's simmer.
Logan's time to shine down here.
Whoa, down
Because
there.
there's decimals. And you can use a calculator for that one. What?
That's heated, bro. Yeah.
The only problem with that is, like, calculators are a totally useful tool, but if you rely too much on them, where you know I'm taking them away, you've got to start building up your tolerance not to be using them. So things like reducing, you probably don't want to reach for your calculator right away. Try to do it on your own, because you'll get better at it the more you practice.
Oh. Not man. Good. Hello, cancel out one class, but it would be like 2 class, you know.
The pies cancel each other out,
But it's like, it's 3
Two.
times,
but 2 goes into 180,
but
90 times.
it's 3 times 5. So when they be 2 times 5.
Pies are gone. You're dividing them over. 5 divided by 5.
But the 3 is multiplying the 5, right?
Doesn't matter.
No, you just get rid of
Like if I have 3 times 5 over 2 times, do 180 over 5. Now you can go ahead and multiply those through and eventually you'll have to reduce it. But the easier thing is to not reduce it and say 5 divided by 5 is 1, and then 3 times 1. And we don't want to multiply by 5, we want to eliminate it because it's that irrational number. Okay, this one is one that you need your calculator for. This one would require a calculator.
Can I just do 550 divided by 100?
So,
You could totally do that, 513, but yeah. So we're saying I'm not going to use the calculator, I'm going to convert it to fraction. So do I need a calculator at this point?
No.
Yeah. You can divide by 5? Well, you can divide by an irrational number. So in this case, whether you start with 5.13 or you change it into a fraction, if I'm giving it to you as a decimal, it's probably on either a quiz or your calculator portion. So those ones I feel comfortable, we could math it out without a calculator. This is something you would use a calculator for.
could you math it out without a calculator?
I could get pretty close, but it's going to involve a lot of paper and me writing a bunch of numbers down, and they're calling me boxes for multiplication. We ain't got time for that in our lives.
I don't
So
get a lot of them.
what?
Yeah.
Do you know how long this lesson is? We'll all be coming in on Saturday.
Put it on, put it down.
293 degrees.
So 5.13 times 180 divided by the pi. Did you use your pi button?
Yeah.
Did you?
Yeah.
Let's go 4 decimal places. Anytime you have to actually do the math for it, you end up with really ugly numbers because it's an irrational number with pi. So you know that you're going to get a decimal that's not nice. Yes.
Can I see it? How did you do it? Yeah, that's what you do.
Okay, how I did it on my calculator? I did 5.13 times 180. Then I hit the equal sign. And then whatever I got for the answer, my calculator will pull the answer from, and then I use my pi button. That's why when the first calculators were created, they were the size of this room, because it stored all the programming. But now you look at your phone and all the stuff that can be stored in there. Yeah. Yeah. You can do your calculator, and I use booklets. So usually all your graphing stuff is in booklets too. And each question that requires a calculator will have a little icon beside the question number that indicates that it's a calculator question. Am I not moving fast enough for you?
Moving plenty fast.
Okay. Complementary angles need to add up to how many radians? Complementary angles need to add up to how many degrees? How many degrees? Complement's nice. Supplement's better. So I told you you had to memorize. If you didn't memorize in the last like 2 minutes, what is the angle measurement in radians for 90 degrees? Pi over 2.
Yeah, and it's also the other one, right? 6.28.
No, that's too fast. Okay, so the radian angle measurement for 180.
Just pi.
Just pi. And that would make sense because 90 is going to be times by 2 to get to 180. If you take pi over 2 and times it by 2, you get pi. So it's all about mapping it out or memorizing. Mapping it out, you have a little bit more skill that you can map out a whole lot of stuff. But some of you are remembering geniuses, and I'm not that kid. So kudos to you, you can just commit it to memory. Okay? Find the supplement of 3 pi over 4. So first of all, what are the two angles measuring up to? So 180 degrees, but this is given in radians. So we want to know they add up to, oh, that's not a good symbol. Let's divide by pi. That's like times by pi. Ah.
Oh, stop doing that.
Sorry. So 180 is the degree measurement of it. Pi is the radian measurement. So we have 3 pi over 4 plus blank equals pi. There's no other up.
Oh, add a page.
What?
Add a page.
On the other page.
Yeah.
Oh, sorry, I have that on the bottom.
Oh, shit.
That's good.
You good, Steve?
Thank you.
Okay, did you guys figure this out? Would it be helpful if you did this? Would that be helpful? Because what's 4 divided by 4?
1.
1. So I got common denominators here. So what do I have to add to 3 pi over 4 to get it to 4 pi over 4? Pi over 4.
No. How would you just say that?
So you could have done it the other way. You could have subtracted. You could have said pi minus 3 pi over 4 gives me my answer. You could have done it that way. Whatever makes the most sense to your brain. Yeah.
So which one?
They can be the exact same answer.
Which is?
Wait, which one would be easier?
That, like, to me, I've worked with radians long enough that I feel comfortable with it. So I can see it like this. Really, guys, all you're doing is adding and subtracting fractions. You just threw a pi symbol in it.
What makes you think I know how to do that?
True story.
What's the supplement?
Pardon? 2 pi? Like here and here. So when you're adding fractions, it would just be like saying 3x over 4 plus 1, that's supposed to be an x, over 4. So you wouldn't multiply the x's. You just say, I got 3 apples, I'm going to add 1 apple. So I have 3 pies, and add 1 pie. to it, I got 4 pi. So, sometimes I treat pi, even though it's a real number, I treat it like it's a variable, because that helps my brain see it a little bit better. You're saying I have 3 pi, I'm going to add 1 pi to it, and I'm going to get 4 pi. All right. Find the complement of 30. Hi guys, ladies and gentlemen, folks, mathematicians. Complement of 30, but expressed in radians. Complement, what are we adding up to?
90. Yeah, I said, you know. I said 90.
I thought you said 180.
So 90, you shook your head.
I apologize. You are 100%. See, you're a mathematical genius.
You did.
You're a mathematical genius. Disrespect. Jonah, do not make me throw your phone out the window.
Bro, you don't think about that one thing.
Bro's on episode 3.
Bro's on episode 3.
He's watching Captain
Steve, get off your phone. Okay. What is the complementary angle here?
Hey, don't say that. That's in the video, Stephen. It wasn't
Okay, what's missing? What's missing? 60, did you need to do any, like, equations for that? You guys probably figured it out in your head, right?
Hey,
Did you
man.
do an equation for it? Okay, but this question doesn't want 60, it wants it as radians. So you Steve, put it down. So you can do it 1 of 2 ways. Guys, this is stuff that's like critical to understanding, and I appreciate we're having fun, Jonah.
Wait, what?
I need you to zip it, start paying attention.
You're on your phone.
Okay, so you can do it 1 of 2 ways. You can convert it using the multiply by pi over 180, or you can do it from your memorization. I know that the angle of 60 is pi over 3, because I know that, I've done this a bunch of times, I've got that sort of memorized. But if you don't know that, take your 60, multiply it by pi over 180. And I'm totally okay if you're a memorizer. You don't have to show me this.
So then 60 would just be like, there'd be nothing else, right?
I don't know what that means.
Like you just drop it out, there's nothing else, right?
Well, it's 1. 1 times pi is, this is already. Sorry.
You can see the one that's not used.
Okay.
Hey, what's your language then?
Okay, last one. You guys do it. You guys do it. I'll tell you if you're right or not.
I don't understand what it's wanting to do.
Hmm?
What is it wanting to do?
Are you taking your
Do it.
Do what? Oh, okay.
That one.
Let me what?
So the complement must add up to 5 or 50.
So that's 90, right?
Okay.
Shut up, Joe.
What do you mean? Oh, this is actually making a lot of sense, Karen. You're
Go
so
back.
cute, that's
Go back into your notes, right? So a complement, you add up to how many degrees? 90. But this question is about radians. So I didn't even write down 90, I did pi over 2. If you want, make sure you include that 90 as well. What do I need here? All the other ones were pretty straightforward. I need common denominators here. What's the common denominator between 2 and 3? 6. So I'm going to rewrite this as,
What's the middle thing?
you know what it is, man.
I'm gonna go with Jonah on this one. So this makes it a little bit easier to see if you go right to common denominators. And so what is it that I need to add to 2 pi over 6 to get it to 3 pi over 6? Just a single pi over 6. So that's my answer. You guys know that, like the different color ones are my actual answer. I find this way showing it makes a little bit more sense when we're doing it. You can make it a subtraction question. You can say, okay, pi over 2 is what I want to finish at. I can subtract what I have, and that will tell me what I need. Really all depends what makes sense in your brain. Okay, we good? Nothing terrible today, it's just that conversion.
Wait, can you go back to this page?
Yeah.
So you're just getting like the common like thing, and putting it at the bottom, and doing it at the bottom to the top.
No, this did not move to the top. What do I have to multiply 3 by to get 6? Jonah? Stop,
He got mad at me for laughing. Look at it.
so if I want 3 to turn into a 6, I gotta multiply it by 2, I have to do top and bottom.
And then you have to do the other side times 3.
Yeah.
Oh,
Okay,
that would be.
I don't, you know what guys,
But then
maybe, okay, you have 13 minutes, maybe we'll keep going, maybe we'll do coterminal angles. Or do you guys want to pick this up tomorrow?
pick it up
Do you guys want to pick it up tomorrow?
Tomorrow.